All right, I want to talk about the moon phase wheel, how to use it. First, I want to talk about the logic behind it, because if you understand it, you don't have to memorize how it works, you just understand how it works. So what I'm going to do is I'm going to have you imagine you go out and it's sunset, and you try to figure out where will the moon be if it's at various phases. So suppose I'm facing due south right now, then west is 90 degrees away to my right, east is 90 degrees away from south to my left. So really, if I face south, I gotta turn all the way over here to see west. I have to turn all the way over here to see east. But what I'm gonna do is give you kind of like a fisheye lens view of the horizon. So here, wide angle lens, let's say here is facing south, and let's say west is here, and east is here on the horizon. It's sunset. So here's the sun setting in the west. Okay? What if the moon is new? We're not going to see it because, remember, the new moon's in between us and the sun. So it's right there with the sun in the sky, invisible to us. But the next evening, remember the moon moves west to east in its orbit around the Earth. The moon will have moved somewhat towards the eastern horizon. How far? Well, full cycle of phases. It moves 360 degrees relative to the sun in about 1 month. So in one day, it moves about 1/30th of 360 degrees relative to the sun. It moves about 12 or so degrees relative to the sun. So the next evening, the moon is a thin, waxing crescent, only about 12 degrees away from the sun in the sky. So I can represent that. Here's that thin, waxing crescent moon, a mere 12 degrees away from the sun in the sky. It'd still be hard to see at this point. It's hard to see a day-old moon, quote unquote. Evening after that, it's now about 24 degrees away from the sun. It's a more waxed crescent, if you will. More of the lit portion is turned towards us. And as the days go on, you get a waxing crescent moon that's getting further and further away from the sun in the sky. And then we know that at first quarter, it's about 90 degrees away from the sun. So the first quarter moon at sunset is high in the sky to the south, because setting the sun over there in the west, I turn 90 degrees, and there's the first quarter moon 90 degrees away, high in the sky to the south. Because we live in the northern hemisphere, we see the moon in the southern sky when it's high in the sky. There's the first quarter high in the sky to the south. And the waxing crescent phases are in between new, when it's right there with the sun, and first quarter when it's 90 degrees away from the sun. So let's draw a representative waxing crescent phase that's the one halfway between first quarter and new moon. But again, in reality, the moon is waxing crescent all the way between new and first quarter. And so every evening you see a thicker and thicker waxing crescent, evening by evening by evening, until about 7 days later, a week later, you've got the first quarter moon high in the sky at the south at sunset. Where's that waxing crescent moon? Well, it's in between south and west. So that waxing crescent moon, I'm seeing that in the southwest sky. Whereas my first quarter moon, I'm seeing that in the south. Full moon, we know that it's opposite the sun in the sky. So roughly speaking, the full moon is rising in the east when the sun is setting in the west. And in between first quarter and full are going to be waxing gibbous phases. So waxing gibbous phases are in between south and east at sunset. They're in the southeast sky. And so again, it's a whole series of them. I will draw the one that's about halfway between first quarter and new. So there's that waxing gibbous phase, halfway between first quarter and new. There it is in the southeast sky. And I can continue this to include phases that are actually below the horizon, not visible at sunset. Those will be waning phases. Waning phases are not visible at sunset because they're still below the horizon. They haven't risen yet, or they recently set in that situation of sunset I meant to say. So the third quarter moon is down here, 90 degrees away from the first quarter moon, and the waning crescent moon, halfway between third quarter and new, would be over here. .45 degrees away from the sun if it's halfway between. And then here's a waning gibbous phase. That is halfway between third quarter and full. So here's waning gibbous. These waning phases are still are below the horizon at sunset, but the waxing phases you can see at sunset. And so let's look further at the logic here and start to relate it to the moon phase wheel. Notice that this waxing crescent phase is some angle that is between 0 and 90 degrees away from the sun in the sky. And so here I'm drawing it like from the south point on the horizon. What you'd really do is point to the sun and then arc your arm slanty-wise to point to that waxing crescent moon. And the angle you get would really be pretty much the same as I'm drawing on the picture here. And so that's how we represent it on the moon phase wheel. So this waxing crescent phase is some acute angle, some less than 90 degree angle. Here would be 45 degrees for this halfway between new and first quarter phase. There's that 45 degree angle eastward on the sky, going towards the eastern horizon away from the sun in the west there. 45 degrees east, or notice it's counterclockwise on the diagram here. So in other words, what I want you to remember and understand, so that you're not memorizing it, you're just figuring it out every time, is that if I have a waxing phase, waxing phases are counterclockwise. Let me put it this way, are east of the sun, or counterclockwise on the moon phase wheel, the MPW, because I don't want to keep saying or keep writing moon phase wheel. So they are counterclockwise on the moon phase wheel are the waxing phases, and for crescent, it's in between 0 and 90 degrees. For the first quarter, it's a 90 degree angle, counterclockwise from the sun. For my waning gibbous, it's some obtuse angle. It's some angle that's more than 90 degrees, between 90 and 180 degrees. So here my waxing gibbous halfway between first quarter and full is going to be 135 degrees in this picture. There's a 135 degree angle there. 135 degrees east, counterclockwise away from the sun for that waxing gibbous phase. So there's that waxing gibbous phase in the southeast sky at sunset. And meanwhile, there's the full moon rising at sunset. Okay? Now, if we consider these waning phases, notice that the angles are in the other direction. And so here is this waning crescent phase, and the angle from the sun to the moon is 45 degrees west. So waning phases are west of the sun, or clockwise away from the sun on the moon phase wheel PW, the moon phase wheel. And I can continue again, 90 degrees clockwise for the third quarter phase, and between 90 and 180 degrees clockwise for the waning gibbous phase. 180, either direction, 180 degrees for the full moon is its angle from the sun in the sky. So it's always the angle between the sun and the moon, basically, that we're after here, and that's directly tied to the phases. The angle, and again, don't memorize this, understand it. The angle from the sun to the moon is eastwards or counterclockwise on the wheel when it's a waxing phase. It's westwards or clockwise on the wheel when it's a waning phase. It's an acute angle for a crescent. It's an obtuse angle for a gibbous. 90 degrees for first quarter and third quarter, 180 degrees for full, and of course 0 for new is how the angles work out. So I've drawn this picture for sunset, but now imagine just the whole sky turning. The whole thing rotates around, so that, for example, imagine turning it all the way around, halfway around, so that the sun goes all the way over to the eastern horizon. All the moon phases continue on with it in tow. So let's draw the situation at sunrise as opposed to sunset. Again, here is our fisheye view of the horizon, south, east, west. It's sunrise, so here's the rising sun. The waning crescent phases are acute angles clockwise from the sun. So let's draw a representative halfway between there. Here's a waning crescent, halfway to halfway between third quarter and new. There's a waning crescent phase that is now, notice, in the southeast sky at sunrise. Meanwhile, the third quarter phase, and notice I'm always turning the lit side towards the sun, by the way, because the sun's what's lighting up the lit side. There's the third quarter phase that is high in the sky to the south at sunrise, because it's 90 degrees clockwise away from the sun, high in the sky to the south. Here's a waning gibbous phase that's in the southwest sky at sunrise. And here's the full moon that is setting when the sun is rising. Continuing on, here's a waxing gibbous phase. It already set before the sun rose. It set about 3 hours ago at about 3 in the morning, because the sun is rising at about 6 in the morning. Meanwhile, here's the first quarter phase that is going to take a while to rise. It's about 6 hours from rising, a quarter turn of the sky from rising. So when the sun has turned 90 degrees in our sky because of Earth's rotation and is high in the sky to the south, that'll bring this first quarter moon 90 degrees over to the eastern horizon. The first quarter moon is rising at about noon when the sky is high in the sky to the south. But at sunrise, that first quarter is way below the horizon in the north. You'd have to face northish and dig a tunnel through the earth to see that first quarter moon. You aren't going to do that, so you're not going to see that first quarter moon. And here, here is a waxing crescent phase that's halfway between new and first quarter. So this waxing crescent phase hasn't risen yet. It's got about 3 hours before it rises. It's going to rise at about 9 a.m. 3 hours after 6 a.m. when it's still about an eighth turn below the horizon there. So again, get this picture in your head of this whole thing turns around. The sun is what's keeping time. We base our clocks on where the sun is in the sky, roughly. Sundials are directly based on that. Modern atomic clocks are based only indirectly on that because the sun itself isn't the greatest timekeeper because of the tilts of all this, that, and the other things. So anyway, now, if you really think about it, when I do these moon phase wheel exercises, it's just rotated versions of what I've drawn for the specific examples of sunrise and sunset. So let's do some examples. I know, I'll do the examples from the exam. Now, of course, give you another exam, won't be the same, but if you can understand these, then you should be able to know other things that I might throw at you. So let's do 34A from the exam, which says, it's 9 a.m., phase of the moon is third quarter, in what direction must you look to see the moon? So 9 a.m., phase is third quarter, what direction do you have to face in order to see the moon? So, let's draw our moon phase wheel. All right, so I'm going to draw a horizon line through the middle. I don't always do that, but I will here to kind of tie in with what we were doing before. There's east, there's south. Well, there's us in the middle, so to speak. I draw south up there on the moon phase wheel to indicate the idea of the moon or whatever, the sun is going to be high in the sky to the south when it's at its highest point in the sky. So I put south up there. The south point on the horizon itself would be like down here, but I put south on the moon phase wheel to say high in the sky to the south is where you'll look. And then below the horizon, there's north. Excuse me. Time is based on where the sun is. The sun is in the east, rising at about 6 a.m. Remember, we're just rounding things off to make it simple. Sun sets about 6 p.m. The sun is high in the sky to our south at noon. If we lived in the southern hemisphere, we'd put north on top and south on the bottom, but we live in the northern hemisphere. And then the sun is hidden well below the horizon in the north at midnight. And it's 9 a.m., so that tells us where to draw the sun because our clocks are based on where the sun is, 9 a.m. So it's halfway between 6 a.m. and noon. So here's the sun at 9 a.m. And then the phase of the moon is third quarter. What direction do I have to look? So it's all encoded in the fact that it's a third quarter moon. So third quarter is a waning phase. Waning phase. And so that says angle from the sun to the moon is, what is it? I'm hoping that you're saying right now clockwise, because waning phases are clockwise away, moves clockwise away from the sun. Angle from the sun to the moon is clockwise based on the fact that we're looking at a waning phase here. And the fact that it's a quarter phase says it's a 90-degree angle. So in other words, what we know is the moon is 90 degrees clockwise from the sun on the moon phase wheel, and now we're good to go. Because I make my sun lollipop, so to speak, draw a line in the middle of the diagram where you are, and then I go 90 degrees clockwise from there to draw my moon lollipop, so to speak. So here's that 90 degrees clockwise angle from the sun to the moon. And so that tells us that the moon is in between south and west. The moon is in the southwest sky. The direction I need to face is southwest. And again, to tie this into what we were doing before, what if I spin this backwards to get the sun back onto the eastern horizon? I go back 3 hours, I spin everything 45 degrees, that puts the sun on the eastern horizon, that puts our third quarter moon high in the sky to the south, just like we said before. At sunrise, the third quarter moon is high in the sky to the south, but 3 hours later, it's moved into the southwest. Notice that if we went another 3 hours to get the sun high in the sky to the south, it'll be noon, and that third quarter moon will be setting at that time. So this all works out logically. It's not just random stuff. You see the logic, you get it. The light bulb goes off, and you can see how to do these things. All right, so that's this one. That's 34A. Let's do 34B. So I'll keep the outline of my moon phase wheel so I don't have to redraw everything, but I'll erase the details. Of course, you have to keep redrawing them, but whatever, life's not fair. So, get rid of the details, keep the rest of the picture intact there. 34B says, at what time does the moon set when its phase is waning gibbous halfway between full and third quarter? So, what time does the moon set? When phase is halfway between full and third quarter. All right, so we know the moon is setting, so that tells us where to put the moon. Moon is setting in the west. Doesn't tell us what time it is. The sun's what tells us the time, but the moon is setting in the west. So I know I want to put the moon right there. And then the phase is going to tell us the angle from the sun to the moon. So it's going to be, this phase is waning gibbous. That's automatic if it's halfway between full and third quarter, but let me put that in there. It's waning gibbous, halfway between full and third quarter. So, waning says angle from sun to moon is, and I hope you're shouting to yourself, clockwise, because the waning phases, it's clockwise from the sun to the moon. Angle from the sun to the moon is clockwise. And it's gibbous, halfway between full and third quarter. So gibbous says it's an obtuse angle, and it's halfway. Full would be 180 degrees, third quarter would be 90 degrees. So this halfway is going to be a 135 degree angle, because it's halfway between 90 and 180 in this case. So now we know then that it's 135 degrees clockwise from the sun to the moon. Angle from sun to moon is 135 degrees clockwise. That gives us everything we need. Gotta be careful. It's sun to moon. Sun to moon is clockwise, so moon to sun is counterclockwise. So in other words, here's the sun, making this angle from the sun to the moon 135 degrees clockwise. So avoid the mistake of accidentally going clockwise from the sun to the moon. It's, sorry, forget what I just said. Don't make the mistake of going from the moon to the sun. It's always sun to the moon that we've been basing this on. So sun to moon clockwise, moon to sun counterclockwise, sun to moon clockwise for this phase. And so what do we got? Well, question was, what time does the moon set? Where the sun is in the sky is what our time is based on. The sun is in between 6 a.m. and noon. It's 9 a.m. when this is happening. That moon is setting at 9 a.m. Again, we can relate to what we did at the beginning. Go back to sunrise, and we've got the sun on the eastern horizon, and that waning gibbous moon has come also 45 degrees, and so it's in the southwest sky at sunrise. But 3 hours later, at 9 a.m., it's moved from that southwest sky over to where it's setting on the horizon. So again, I hope you can see the logic in all of this. It's all very logical. All right, one more. We'll do 34C. So again, let me erase the details so that I can reuse my diagram. C said, it's sunrise and the moon's in the southeast sky. What phase is it? So we already did this at the beginning. We did all the phases that are sunrise visible, but we'll just do it again using the moon phase wheel, starting from scratch. It is sunrise. And moon is in the southeast sky. It's sunrise, okay? There's the sun rising the east. Moon's in the southeast sky, so I can put it anywhere between south and east, so I'll just split the difference. There's my moon. There's my moon lollipop, my sun lollipop, so to speak. What's the angle from the sun to the moon? Well, if I do it halfway, it's 45 degrees. Although what's really important is it's in between 0 and 90 degrees if we're in the southeast sky. It doesn't have to be exactly 45 degrees. 45 degrees west or clockwise. Wheel. So we deduced from the fact that the sun is in the southeast sky there that it's an acute angle clockwise from the sun on the moon phase wheel. So acute says the phase is crescent. Obtuse is gibbous, more than 90 degrees. Acute is crescent, less than 90 degrees. 90 degrees for the quarter phases, 0 for new, 180 for full. Acute angle, oh, it's so cute. Acute angle is crescent, and clockwise says waning. Aha, there's our answer. That is a waning crescent phase that is in the southeast sky at that time. And again, I hope you can see the logic. If you're out at sunrise, then waning phase is the one that's visible. And if it's in the southeast sky, it's less than 90 degrees from the sun, so it's a crescent phase, so it must be a waning crescent phase at this time. I can do that even without drawing the moon phase wheel, but drawing the moon phase wheel makes it systematic. And remember that I'll want you to explain your reasoning, and the moon phase wheel can do, otherwise you have to write some words to explain how you came up with all that. So, those are some examples. I strongly recommend going back to the exercises on the phases of the moon posted on Blackboard and go through them. And there's 12 examples, problems at the end. So do those. See if you get them right. Posted the answers. see if you can get them right. If you do all those, then you're gonna be good to go, and you're gonna get those points when you take the exam. Alrighty.